For today's problem, I will be doing problem number 2 from section 3.10. And this problem states, assume that all variables are implicit functions of time t. Find the indicated rate. So they want us to find the derivative of y with respect to t, which is going to give us a certain rate of change. And we are given the function x squared plus 5y squared plus 6y equals to 43. They also give us dx dt, which is equal to 12, and x equals 4, and y is equal to negative 3. So the first step to solving this problem is to take the implicit derivative of the function given, the x squared plus 5y squared plus 6y equal 43, with respect to time t. So as you notice, none of these have the variable t for time in it, so it's going to look, when we did implicit differentiation and we had like a dy dt or dy dx after all the terms, since nothing will cancel out. So to take the derivative of that, we start with this. So we're going to have derivative with respect to time of x squared plus d over dt of 5y squared plus d all over dt of 6y equal to derivative with respect to time of 43. So then starting with this, we're going to bring down the 2 and have 2x dx dt plus, and bring it onto the 2, so we have 2 times 5, so we're going to have 10 y dy dt, and then we're just going to have 6 dy dt, and then the derivative of any constant is always 0. Which then we can, what we want to do, since we're solving for, again, we're trying to find dy dt, we're going to isolate that variable. So how I'm going to do that is I'm going to move over, or keep the dx dt on one side and move over my dy dt's to the other side. So I have 2x dx all over dt equal to a negative 10y dy dt minus 6 dy dt, since I brought those to the other side of the equation. And now we have 2x dx dt equal to minus 10y dy dt minus 6 dy dt. And so we can simplify this further to be 2x dx over dt equal to, and I'm going to pull a dy dt out of both terms, dy over dt, so then that'll be, on the inside of this we'll have a negative 10y, since that's a negative 10y dt, minus 6, because then we have the minus 6 dy dt. Now the next step that we know, we have dx dt here, and they gave us the dx over dt is equal to 12. So we can just plug that value in. So I'm going to rewrite this one more time with 2x and dx over dt is 12 equal to dy over dt minus 10y minus 6. And then if we rewrite this, we're going to get 24x here, and then this whole section. And then when we want to get dy dt by itself, we're going to divide this from here to cancel it out onto both sides. So I'm just going to do that part right now, because that's going to cancel that out, and it's going to go over onto that side. So we're going to get dy all over dt is going to be equal to, and on the numerator we're going to have that 24x I'll put that up here. And on the denominator, it's going to be what we divided by. So the negative 10y minus 6. And I'm just going to pull out the negative and make it 10y plus 6, because it's still negative 10y minus 6. So, for the first step, taking an implicit derivative of this function, dy over dt is 24x all over a negative 10y plus 6. But since we need to find the rate, the second step is to plug in the x and y values into that equation. So I'll rewrite one more time what our dy over dt was. It was a 24x all over negative 10y plus 6. And looking back from my other page, they told us x is 4 and y is negative 3. So when x equals 4, and y is equal to a negative 3, and we just plug those values in. So we're going to get 24 times 4. On the bottom, we're going to get a negative 10 times a negative 3 plus 6. And then that gives us, just going to start canceling out some terms. 24 times 4 times negative 30 plus 6, which then gives us 24, 4. And we have negative 30 plus 6 is a negative 24. Negative 24 times a negative is a positive 24. And since we have the same thing on the top and bottom, we can cancel those out. And we're just left with 4. So then our answer for the rate of the change for dy dt is equal to 4. And that is how you solve problem number 2 from 3.10.